The SweejTech HDR system uses values that represent dB/SPL, sound pressure level, a loudness realm where 0 equates to inaudible and amplitude doubles with every 6 dB added. This means HDR loudness values work on a positive scale from 0 to 220, similar to real-world sound pressure measurements, rather than the negative dBFS or full scale, -96 to 0, used for digital audio signals. HDR loudness is a system focused on perceived loudness rather than signal amplitude, where you define how loud you want sounds to be and whether you want these sounds to potentially duck other sounds or be ducked themselves. It works alongside other volume modifiers such as the volume settings for an actor, an asset, or a sound class. But in terms of workflow, it's probably best to keep these set at 1 so that the HDR loudness values you apply are more transparent and readable. You can set the loudness of a sound within the asset itself via the SweejTech HDR drop-down menu, or within the HDR authoring window. Whether a sound is likely to duck other sounds or be ducked by other sounds is largely determined by this loudness value and its relationship to the resting loudness of the system. This resting loudness value is found in Project Settings, SweejTech HDR, and it's set by default to 80. The resting loudness level of 80 is not arbitrary. It corresponds to the stapedius reflex, sometimes called the acoustic reflex, that naturally occurs in human hearing around 80 dB/SPL at 1 meter. This is an involuntary contraction of the stapedius muscle, which attempts to protect the inner ear from damage. When sounds are at this loudness level, their playback will be the same as without HDR, which is often a good starting point, so think of 80 as your natural home base for sound levels. In broad terms, after taking into account attenuation, any sounds that are metered above this resting level will cause the system loudness to rise, and as a consequence other quieter sounds will be ducked. Let's look into the nuance of exactly how and why this happens. Just to note that as well as the loudness value, sounds may have loudness offsets. For example, this M16 weapon sound has a loudness offset of +4 dB as it belongs to the weapon's loudness definition, and so this specific sound is being offset from its inherited value. Let's watch the values in the HDR activity window for this tank sound. Its defined loudness is 70 and there are no loudness modifiers, but attenuation settings are taken into account to produce a distance loudness value. For example, if I change its attenuation settings from logarithmic to linear, you can see that value change. So this exactly recreates the usual Unreal Engine attenuation effects on volume, only now it's acting within the HDR system. This distance loudness value then acts as a multiplier on the actual metered signal to generate a momentary loudness value. Let's switch on an LFO within that meta sound to hear the effects more clearly. So here my distance value has not changed because I'm not moving. However, the metered level of the signal is changing and therefore it gives us a changing momentary loudness value. So just to recap, the defined loudness of a sound and any loudness modifiers are combined with the sound's attenuation settings to produce a distance loudness value. And this is then combined with the actual metered level of the sound to produce a momentary loudness value for this sound. And the next bit is where the magic happens. The HDR system constantly evaluates the momentary loudness of all HDR sounds to identify and set the max momentary loudness. So out of all the sound's momentary loudnesses, which is the loudest? In the HDR envelope window, the yellow line is showing us the max momentary loudness. At the moment there's only the tank sound playing, so the momentary loudness of this, of course, is the max momentary loudness. And we can see how this follows the momentary loudness of the tank if we change distance or switch on that LFO again. So the way the HDR ducking system works is as follows. If this max momentary loudness goes above the resting loudness of the system, which is 80, this then pushes up the system loudness, and it does so over a specified attack speed and release speed. The tank's loudness of 70 combined with its metered loudness is never going to do this, so let's introduce another sound. So the M16 rifle belongs to the weapon's loudness definition. That gives us a loudness of 112, and then it's got a local modifier of +4, so its loudness is 116, fairly loud. So this is above the resting loudness level of 80. And here in the envelope window, you can see the M16 sound move that max momentary loudness value, since it currently has the loudest momentary loudness. And this in turn pushes up the system loudness. As you listen, you'll notice the effect that that has on the other sounds, in this case the tank. We'll just mute the weapon's loudness definition so we can hear the ducking effects on that tank sound more clearly. As the system goes above the resting loudness, it wants to duck the other sounds down by an equivalent amount and still retain their relative relationships to each other, so this calculation is made. Each sound's resulting level is a product of its distance loudness minus the system's loudness. If we pause the game there, we can see that the distance loudness of the tank is 69 and the system loudness is 96, so 69 minus 96 gives us a resulting level of -27. Let's add in a couple more sounds just to verify that system. So here we have an exterior sound and the sound of a water fountain. And if we bring up that weapon again, pause the game and examine those values. So the weapon, the loudest sound in the scene, is governing that max momentary loudness value, which in turn is pushing up the system loudness, which is 93 currently. Looking at the fountain, the distance loudness is 70, so 70 minus 93 gives us a ducked resulting level of -24. It's -24 because system loudness is actually nearer to 94. And then we have the quad exterior sound, which is distance loudness 76 minus 94, and that gives us a ducked level for that exterior sound of -18. If we unpause the game, the other thing you'll notice is that these changes happen over time. So let's look at the attack and release settings. So here in the HDR controls window, we can see that the attack speed is set at 250 and the release speed at 20. So the attack speed is the rate of increase of the system loudness in decibels per second. So at this default rate of 250, the system loudness will increase up to whatever the max momentary loudness is at a rate of 250 decibels per second. So there's that attack happening there on the system loudness, and if I increase that speed to 500 decibels per second, you can see the change here. It's responding much quicker. And if I slow it down to something crazy like 20, you can see it's extremely slow to react. So you'll want to play around with these attack and release speed settings according to the nature of the sounds in your game. Now we might want the ducking effects to have an attack and release speed, but we don't necessarily want this attack to affect the nice transients of the loud sounds that are causing the ducking. So while a sound's momentary loudness is higher than the system loudness, a gain equal to that overshoot is applied, up to this max overshoot value. This is the maximum gain in dB that can be applied to any sound's output send. Its default is 4. If I trigger a loud explosion and we watch its resulting level, you can see that it gets capped at 4 dB. And if I change the value of the max overshoot to 2, Again, you can see that it's being capped. Another HDR setting that you might want to experiment with is post gain. Again, this can be set via the asset in the SweejTech HDR drop-down menu, or in the HDR authoring tab, either directly or as a modifier to the inherited value coming from its loudness definition. Post gain is applied, as the name suggests, after all the HDR loudness calculations. So it might be that your sound is ducking the other sounds in the way that you want, but it's actually a bit loud. So for example, that grenade sound might be ducking the sounds in a super impactful way that I want, but in terms of the overall mix, it's a bit loud. So I can add a post gain modifier here of -6. To get it a bit more under control. Another setting that you apply in the authoring window, or is inherited from the loudness definition of a sound, is the HDR mode. Full mode is what we've just been hearing with the grenade and the M16 rifle. Sounds affect and are affected by the system loudness. Read mode is when the sound is affected by the system loudness but doesn't drive it. This is intended for sounds that should duck when important sounds play, but shouldn't duck other sounds themselves. Write mode affects other sounds, but is not affected by the system loudness. It's perfect for sounds that must always be heard, like critical UI sounds. And finally, static mode allows you to opt out of the HDR system, whilst still being able to use loudness values for your sounds in the same shared decibel domain as sounds that are included in the HDR system. This might be particularly appropriate for dialogue, music or UI sounds in order that their playback levels remain consistent. If you just turned off HDR for these sounds, then the loudness value would no longer apply, and it's likely to be confusing working in dBSPL 1 minute and standard Unreal Engine volume multipliers the next. Finally, while we've got this HDR controls window open, let's look at culling. HDR allows the culling of one-shot sounds that are metered below a threshold based on the system loudness. So for example here, we've got a culling threshold offset of 20. So if we enable HDR culling debug, we can see that a red line appears in the HDR envelope window, and that's showing us the culling threshold offset. So it's tracking the max momentary loudness at 20 dB below. Culling allows us to improve performance by saving on the CPU used by the audio system in dense soundscapes, where it's known before sounds play that they'll be inaudible when they start. So I'm going to play some random sounds around the player. These are being spawned at different distances, and I'm going to shoot my weapon. You'll see that culling threshold rise up, and that any sounds that attempt to spawn that are below that threshold will in fact be culled. So those automatic weapon fires that are being spawned into the world were culled because the max momentary loudness was quite high because of my weapon, and therefore they fell under that threshold for culling. So that was a roundup of the general principles on which the SweejTech HDR system works.